Hello, hi everyone. My name is Chaitanya. I am studying in Sri Venkateshwara College of Engineering from the Department of ECE, 7th semester. The subject is Automotive Electronics and the topic is the protocol model and message format of CAN bus, lean bus and most bus. Firstly, we see a introduction. A controller area network CAN bus is a vehicle bus standard designed to allow microcontrollers and devices to communicate with each other. It is a message based protocol designed originally for multiplex electrical wiring within the automobiles to save on copper, but it can also be used in many other contexts. For each device, the data in a frame is transmitted serially, but in such a way that if more than one device transmits at the same time, the highest priority device can continue while the other pack of CAN bus. In 1991, the CAN bus was the first bus system to be introduced to motor vehicle in mass production. It is since established itself as a standard system in the automotive sector, but the CAN bus is also commonly used as a field bus in automation engineering in general. In imitation of other network types such as the local area network, wide area network, a personal area network, this bus system was given name of CAN. Applications of CAN. The CAN bus is finding ever more use in vehicle diagnostics. Here the electronic control units is connected directly to the CAN bus and thus receives the information it needs for diagnostic immediately. Previous diagnosis interfaces are becoming less important. CAN protocol. For communications protocol, it is standards practice to arrange thematically coherent tasks as the set of layers, which offers a high level of flexibility in the implementation of a bus system. With the CAN, both the CAN hardware and CAN software are subdivided into the several layers. Protocol layer. Here we see first layer is application layer. The application layer represents the information in the form of data structures used by the application. This set of data which are to be transmitted or forwarded to the object layer for these purposes. And second one is object layer. The task of the object layer is to manage the messages. The functions of the layer are used to decide which messages should be sent at which time. For incoming messages, this layer is responsible for messaging filtering. Transport layer. The transport layer furnishes the object layer with received messages and processes the messages prepared by the object layer for sending in such a way the physical layer is able to transmit this information to fulfill this purpose. The transport layer is responsible for such a function as abbreviation or flatter detection and single signaling. Physical layer. The physical layer is the lowest level in the transport stack. It consists of the physical components of the network such as wiring and voltages used to send the information. Here we see the CAN message format. First, data frame. The transmitted message contains data that it provides by the transmitting station. Remote frame. Stations can request the data they need from the data source. The windshield wiper requests how wet the windshields is from the rain sensor. The data source responds by sending the relevant data frame. Error frame. If a station detects a fault or error, it communicates this to the other stations using the error frame. Overload frame. This can be used to create a delay between a preceding and subsequent data frame or remote frame. The transmitting node reports that it cannot currently process another frame. FEC end of the frame. The end of the frame marks the end of the messages and comprises 7 receiver bits. with the 7 bits of the same value in succession. The stuffing rule is deliberately broken. Interframe space. The interframe space compares a succession of three received bits which serve to separate successive messages. After a total of 10 of these received bits, the stations are permitted to being transmitting within the network again. Until then, the bus remains in idle state. Only data and remote frames needs to include interframe space. Error and overload frames can be sent immediately after the last frame. This enables immediate signaling of errors and problems. Line bus. Line bus is a supplement to CAN bus. It offers lower performance and reliability but also directly lower costs. Low cost option often used in vehicles for windows, wipers, air condition, etc. Line clusters consists of one master and up to 16 slave nodes, single wire, time triggered scheduling with the granted latency time. Line bus application: string wires, cruise control, wiper, climate control, radio, comfort sensor for temperature, sun, roof, light, humidity, powertrain sensor for position and speed, pressure, engine, small motors, cooling fan motors, and air conditions, motors, control panel, and doors, side mirrors, windows, seat control, locks, seats, position motors, pressure sensors, and others will in window, wipers, rain sensors, headlight, airflow. How does line bus work? Line communication at its core is relatively simple. A master node loops through each of the slave nodes, sending a request for information, and each slave responds with data when pulled. The data bytes contain line bus signals. However, with each specification update, never feature have been added to the line specification, making it more complex. Here we see line bus work. Line frame format. In simple terms, the line bus message frame consists of a header and a response. Typically, the line master transmits a header to the line bus. This trigger a slave which spends up to 8 data bytes in response. Most bus. The most bus serial bus uses a daisy chain or ring configuration of distribute audio, video, voice, and data signals. These signals can travel on fiber optic circuits or by wire. Right now, the most system can handle up to 65 devices in the typical daisy chain configuration. None of the manufacturer have that many systems and module on their most protocol communication lines as of yet, so there's plenty of room for growth and additional system. Features of Modbus. The Modbus supports the logical networking of up to 64 devices, at which point constraints associated with the cheapest may be encoded in its current version. The Modbus offers a data rate of 24/8 mbit and version with higher data rates of 50 mbit, most 50, and already it's available as a development model. Thank you.